Hi, good day everyone. So today we continue our lesson on chapter 3, electric current and direct current circuit. For 3.1 we have electrical conduction, and then for learning outcome 3.1a you have to describe microscopic model of current and emphasize on the flow of free electron in metal, include the concept of drift velocity. Alright, so we go one by one. First one is the electrical conduction metal. Alright, remember in metal, the charge carrier is free electrons and a lot of free electrons are available on it. So remember, in metal, the charge carrier is free electron. They will move freely, randomly and haphazardly through the crystal lattice structure in the metal, but frequently interact with the lattice. So maksudnya dia akan contact juga dengan crystal lattice structure of the metal. And then when the electric field is applied to the metal, so meaning that the current is set up in the circuit, the freely moving electron experience an electric force. Okay, and then tend to drift with constant average velocity, called the drift velocity, towards a direction opposite to the direction of the field. Okay, so kita tengok direction of field. Okay, so this one is we have positive terminal and negative terminal, and then the electric field is set up from positive to negative. Okay, from positive to negative we have the electric field. Okay, but we have the free electron moving in the metal, and then the free electron is negative. Okay, so mestilah dia akan attend, direction of electron flow is from negative to positive terminal. Okay, so dia akan opposite the direction of electric field, sebab direction of electric field is from positive to negative, so direction of the electron flow is opposite to the direction of electric field. Okay, the electron accelerates because the electric force acted on it. Okay, remember here, this one, electric current is flowing in the opposite direction of the electron flow. So kalau electron flow, okay, this is the direction of electron. Okay, remember this is the direction of electron. Okay, it is opposite to the direction of current. Okay, alright. Okay, so for 3.1b we have to define current. What is current? Current is defined as the total net charge or total charge flowing through the area per unit time. So mathematically we have I is equal to Q over T. It is based on scalar quantities. The unit is ampere. So kalau soalan tanya what is defined by 1 ampere, 1 ampere is defined as the 1 coulomb of charge passing through the surface area in 1 second. Kalau soalan tanya what is meaning by 100 ampere, so 100 ampere is 100 coulomb of charge per 1 second. Okay, and then for 3.1c, okay, 3.1c, we have to use the electric current where I is equal to Q over T, and remember that Q is equal to NE. Q is the number of electron and E is the elementary charge. Which is 1.6 times 10 power of negative 20 coulomb. Okay, we go to example number 1. A silver wire carries a current of 3 ampere. Given a charge of electron is 1.6 times 10 power negative 19, determine the number of electron per second pass through the wire. Okay, so we know that Q is equal to IT. And then the number of electron kan, kita nak number of electron, so number of electron N per T. Okay, so from where we can get N per T? So we know that Q is equal to NE, NE equal to IT. So N over T is equal to I over E. So number of electron per time is equal to current is 3, and E, the charge of electron, 1.6 times 10 power of negative 19. So N over T will be 1.88 times 10 power of negative 19 electron per second. Okay, electron per second. Okay, the B, the amount of charge. Amount of charge flows through a cross-sectional area of the wire in 55 seconds. So the amount of charge is Q. So Q is equal to IT. So Q, I is 3 and T is 55. So Q is 165 coulomb. Okay, 165 coulomb. Alright, so then for example 2, a current in a bulb is 2 ampere. What is the charge that flows through the bulb in 5 minutes? Okay, charge. So Q is equal to IT. So Q, I is 2, T is, okay, in minutes. So you have to convert to second, 5 times 60. So Q is 6,000 coulomb. Okay. And then soalan seterusnya, how many electron flow through the bulb in 5 minutes? Okay, how many electron maksudnya how much electron, nak cari N lah. How much electron, how many electron. Q is equal to NE. So N is equal to Q over E. So Q is 600 coulomb. E is 1.6 times 10 power of negative 19. So N is 3.75 times 10 power of 21 electrons. Okay, 1 electrons. Okay. Okay, so this 3.1. So for 3.1 we have microscopic model of current. Microscopic model of current. Okay, so I explain again the microscopic model of current. Remember, in metals, free electron act as charge carriers. Without battery, potential difference is 0 with no electric field. And then free electron undergoes random motion. So, random motion. And then when a potential difference is applied across a metal, an electric field is set up in the circuit. This field exerts an electric force on the freely moving electron. And then electron yang move secara randomly tadi, dia akan jadi the free electron will drift towards the end, which is at the higher potential difference with constant average velocity. Alright, so kat sini mula-mula dia move secara randomly and haphazardly. Okay, so once the potential difference is set up in the metal, and then bila potential difference set up in the metal, so remember that electric field is set up in the circuit. So ada electric field from positive to negative. Dan dalam masa yang sama kita ada electron, the drift electron akan move from negative to positive. Okay, ini adalah direction of electron, drift velocity of the electron. Apa dia drift velocity ni? Drift velocity is the average velocity attained by such particle such as electron in the metal due to the electric field. Okay, so cakap it causes all the free electron drift along the metal in the direction opposite to the direction of electric field. Okay, so kalau perlu perasan kat sini, this one is the direction of electric field, okay, direction of electric field, tapi direction of electron or direction of drift velocity of the electron is opposite to the direction of electric field. Okay, as they drift, they collide with the ions in the lattice and accelerated. Okay, so dekat sini kita ada ini direction of E. Okay, direction of E, remember. Okay, so direction of drift velocity is in opposite. Okay, ini kita ada electron, the drift velocity of electron is opposite to the direction of electric field. Okay, so then this is for electric current. I explain again. For the electric current, state the rate of charge flow through a conductor. Mathematically, we have I is equal to Q over T, where Q is the magnitude of charge and T is the time. And then we also have Q is equal to NE, where N is the number of charge and E is the charge of electron. So you can have Q is also equal to NE. Okay, remember that the small n or capital N is all the same, where N is the number of charge. Okay, the unit is ampere. It is a scalar quantity measured by ammeter.